Okay, let's talk about the trade-specific assignment. So each of you were asked at the beginning of class which trades you were receiving your certificate or your degree in. This assignment is designed specifically for that trade. You will be required to complete 15 questions on this assignment. I would encourage you to begin at least 1 month before the class is to end. This is a test grade that cannot be excused. You have to do this assignment to complete this course. You must turn in this assignment to pass this class. This tests are worth 50% of your grade in this class. You can find a guided notes handout under the content section in Blackboard. There is a video with each section. You should only do the section that is for your trade. This video gives guided examples of each of the problems for you. Under each guided problem, there is space for you to work the actual problem in your test. You should watch the video with the guided examples and take notes before you attempt the test. If you should happen to get the exact same problem with the same numbers as the guided example, pick a different problem. You will have unlimited times to get the problems correct. You must turn in notes from your test, or 20% will be deducted from your test grade. You can turn in the notes that I have provided, or you may take your own notes with the problems numbered. You may turn these in by scanning them or scanning them to my email, or dropping them by my office, or handing them to me in class is fine too. In order for your grade to not receive the deduction, you must turn them in within 24 hours of completing your test. So you might want to have my email ready, or might want to jot down my email. It's mhill@uaptc.edu. Okay, let's look at the first problem. A machinist receives a sketch of a part he must make, as shown to the right. If the indicated angle, BAC, is precisely half of the angle BAD, find angle BAD. So what we have here is we have this angle that they're talking about, angle BAC. Angle BAC is, when you look over here, we're talking about this angle right here that they've got drawn for us right here. So this angle BAC, and they tell us something about that angle. They say that this angle is 18 degrees, 33 minutes, and 41 seconds. Okay, now they're asking us to tell them what the measure of this entire angle is. Angle B, starting with B and going to A and ending at D. So they want us to go over and say, well, what is angle BAD equal to? So this whole angle here. And they also give us some other information that basically says that angle BAC is precisely half of the other angle. So we know what we need to do is multiply this by 2, or add 18 degrees 33 minutes 41 seconds to 18 degrees 33 minutes 41 seconds. So either way it's fine. I'm going to just multiply everything by 2. Okay, so I'm going to take 2 and multiply it by all of this stuff. So 2 times this, 2 times this, and 2 times this. Well, 2 times 18 is 36. 2 times 33 is 66. 2 times 41 is 82. Now, I want to be careful because this is not my final answer. I need to reduce this. So you need to know a few facts in order to do that. And I know that this is weird that they're called seconds and minutes, but it's very similar to time. in the aspect that this represents our seconds, and there are 60 seconds in 1 minute, and there are 60 minutes in 1 degree. Okay, so when we look at this, we want to start on this side and say, do I have more than 60 here? Well, yes, I do. I have 60 will go into 82 one time, and if you do 82 minus 60, you would have 22 degrees left. Well, that one that I divided out would go over to the next unit, so I would have 67 minutes, 36 degrees. So I took care of that. Now I want to look at this middle term, this minutes term, and says, well, do I have over 60 here? Well, yes. I have 7 over 60. So I have enough to make 1 degree more, so it's 37 degrees. And since this is 67, 67 take away 60 would give me 7 minutes and 22 seconds. So this is going to be my final answer. Okay. In the pipe flange shown below, the 6 bolt holes are equally spaced. What is the spacing of the holes in degrees? Okay, here's what we know about this problem. We know that there are 360 degrees in a circle. So, if these holes are divided evenly among the circle, then, and there are 6 of them, I should just be able to take 360 divided by 6, and that's going to get me 60 degrees. And so, what is the spacing between the holes? 60 degrees. Find the perimeter and the area of the figure. We're going to assume that these are right angles and the parallel sides except for where obviously otherwise. So they're just saying that this is a right angle. We're talking about a rectangle here, and these are parallel sides. And it says that these are in inches. So to find the perimeter, you're going to add up all the sides. So we would do 12.5 plus 23.6 plus, so we're just going around the edge of the rectangle, 23.6 plus 12.5. Well, this up here would also be 23.6 inches. And then this across from here should be also 12.5 inches. Okay, so I want to add 23.6 again and 12.5. When I add those things together, that is going to get me my perimeter. Okay, and that gives me a total of 72.2 inches. So my perimeter is 72.2 inches. Okay, next thing it asked me to do is find my area. To find area, you would do length times width. So 23.6 inches times 12.5 inches. Okay, inches times inches is going to get me inches squared. So in my answer, I want to write inches squared. 23.6 times 12.5 ends up being 295 inches squared. Okay. A roll of gasket material is 18 inches wide. What length is needed to obtain 16 square feet of the material? So what we're saying here is that we have some kind of material that's rolled up. So if you think kind of about like a soup can or something like that, if you roll it up and you take the label off the soup can, we could roll it out. Okay, and what they're telling us is that this is 18 inches wide. So when we roll it out, this part of the ribbon or this part of the soup can, which is our gasket material, is 18 inches wide. We don't know what the length of the material is, but what we do know is that the area needs to be 16 square feet. Okay, so we need to make sure that when we do length times width, we get 16 feet squared. So since this is in feet, I'm probably going to change this 18 inches into feet. So what I know is that there are 12 inches in a foot. So this would be enough to make 1 foot with 6 inches left over, and 6 inches would be half of a foot. So this 18 inches is really 1.5 feet. So I'm going to plug that right in here for the width, 1.5. I know that. Since we're going to kind of change to talking about algebra a little bit here. I'm looking for the length, but I know the length times 1.5 is equal 1.5 feet, sorry, is equal to 16 feet squared. So if I want to find this missing length, I should be able to divide by 1.5 feet on both sides of my equal sign. Okay, and that's going to get me, these cancel out because they turn into 1. 16 divided by 1.5 is 10 and 2/3. My calculator's actually giving me 10.6667. If I did math, enter, and changed it to a fraction or a mixed fraction, that would be 10 and 2/3. And so I've got feet and I've got feet squared. Well, this feet is going to take one of these feet squared, so I would have feet here. So 10 and 2/3 would be the exact answer. Feet would be the exact answer of the amount of length that I would need to have if my width was 18 inches and I need to have 16 feet squared of total area. And this is a sheet of 19-inch by 27-inch paper. So we're looking at something that is 19 inches this way. When we go across this way, it is 27 inches. And this thing must be cut into 4 by 6 inch cards. Okay, so the cards may be cut in either direction, but they must be consistent. Which plan will result in the least amount of waste, cutting the 4-inch side of the card along the 19-inch side or of the sheet, or along the 27-inch side? So I'm basically going to draw two drawings here. They're both going to be my 19 inches by 27 inches, but I'm going to arrange my cards that they're talking about so I can see what's going to leave me the least amount of waste. So my options were, the card is a 4 by 6. So when you think about it this way, 4 will go into 19 4 times with 3 left over, right? Because 4 times 4 is 16. And so if I wanted to get to 19, I would have 3 left over. So I'm going to kind of divide this into 4s. But what I know is that I actually have a little bit of leftover space. This part down here is not going to get used. Okay, and this little space down here is 3 inches, because this is 4, 4, 4, 4, and 3. All of those need to add up to be my 19. Okay, so I didn't have enough to put one more card down here. Now, when we go, the cards are 4 by 6, so we would, if we're going to do it this way, we're going 6 inches this way. Well, how many times will 6 go into 27? Okay, so 6 times 4 is 24, so 4 times, because we don't have enough to make the extra. So if we did, here's one that's 6, there's another one that's 6, this is 6, got another one that's 6, so that's 24, but we've got to get to 27, so from 24 to 27, we've got a 3-inch section right here that's just left over. Okay, so these are actually the pictures of what our cards would look like that we're cutting out. So if we come right here, so each one of these little sections are a card. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we would get 16 cards out of this. But we've got some leftover space right here. So this space that we have is the area that's waste, basically. So we've got something that is 3 inches by, if we just talk about this little space in here, okay, this is a 3 by 19. And I'm gonna include we're talking about this area right here. All of this stuff in here. So this is a 3 by 19. So 3 times 19 is 57 inches squared. So that's waste on this paper. Then I've got some more waste when you talk about this section right in here. Okay, all of this stuff right here. Well, this is a 3 by 24 because we've got 6, 6, 6, 6. So 3 by 24. That's going to be waste right there. We already included this section in this darker blue. So 3 times 24 is going to get me 72 inches squared. And when you add those two numbers together, I'm going to have the 57 inches squared plus 72 inches squared. That's going to get me total waste of 129 inches squared. So there's what we know about that one. Now we've got to look at our other option here. And our other option, we're going to turn the card so that it is the 6 part goes this way and the 4 part goes this way. So how many 6s will fit into 19? 6 times 3 is 18, so I think I'm going to be able to fit 3 cards with 1 inch down here left over, right? This would be 6, 6, 6. So 6, so 6 times 3 plus 1 would get us our 19. Okay, now the 4 part of the card is going to go this way. So how many 4s will go into 27? Well, 4 times 6 is 24. So we could probably fit 6 of these things this way, 4 sections of 6. So 1, 2, 3, 4, 5, 6, and we're going to have some left over. And I didn't do a very good job about drawing that to scale, but there's our sections of 4, and then we're going to have 3 left over. If you add all that up, you would get 27. Okay, and so we can draw out our little cards here. Okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 cards. Okay, so we were able to do 18 cards this way, and the waste, so our total waste is going to end up being 1 by, right, we would come down here and look at this little area in here, and this is 1 times 27 because this is 27, so it would be 1 times 27. That's going to get me 27 inches. So I have a waste of 27 inches plus this other part, this little section right in here, which looks like it is 3 by 18 because we've got 6, 6, and 6, so 3 by 18. And 3 times 18 is 54. Okay, and so when we add 54 inches and 27 inches, I'm going to come up with 81 inches squared, and both of these should have been squared. I'm sorry, because we're finding the area. So the question says, which way is going to produce the least amount of waste? Well, it's this one. This is going to be our 81 inches squared. Is going to be the least amount of waste. And we're also able to produce 18 cards that way. So this is the one, so it says cutting the 4-inch side of the card along the 19-inch side. Well, that would be this option, because here's the 19-inch side and we're cutting the 4-inch card. So no, not that one. Cutting the 4-inch card along the 27-inch side. So yes, we took the 4-inch card and cut it along the 27-inch side. So this is the correct answer. Right? Which plan will result in the least amount of waste? And this is the right answer. We got 81 inches of waste versus 72 inches of waste. We were able to cut 2 more cards on this way. Okay? Okay, so it says a contractor is needed to build a small workshop. He found a pre-engineered steel building advertised for $12,024. If the building is a 24-foot by 24-foot square, what is the total cost of the building per square foot? So we're looking for cost of the building per square foot. So we're looking for dollars divided by square foot. So I know the dollars part. I can find the square foot by doing 24 foot times 24 foot. Okay, 24 times 24 is 576 feet squared. So then we want to divide by, so we've got dollars divided by square feet. So we want to take the number of dollars that we have, which we said was $12,024, divided by the number of square feet we found. Okay, so 12,024 divided by 576, and we're getting 20.875. The 5 would make us round up. We're talking about money here, so we're probably going to round up. You want to pay attention always that you round to whatever they tell you to round the answer to. So $20, 20.88, if we're going to round up, dollars per foot squared. Okay. Find the missing dimension of the figure shown to the right. Round to the nearest tenth. Okay, so both of these are in inches, and this is a right triangle. So you use something called the Pythagorean theorem. A squared plus B squared is equal to C squared. Okay, C is always the hypotenuse, and the hypotenuse is always across from your right angle. So this is going to be C. We don't know what it is. The other two sides that are connected to the angle to the right angle are called legs, and it doesn't matter which one we call A and which one we call B, but those are your A and your B. Those are the legs. They're connected to the right angle. C is the hypotenuse, and it's always right across from the right angle. So in this problem, if I let A be 8, I would have 8 squared plus B, which is 13 squared, is equal to C squared. So I'm going to do 8 squared plus 13 squared okay, and that's getting me 233 is equal to C squared. Now I want to know what C is, not C squared. So to get rid of a square, you have to take the square root. So we're actually going to take the square root of both sides, so square root of 233, and take the square root of C squared. That's going to undo the squared, so I just get C. And the square root of 233 is equal to And I'm getting a decimal number that is that goes on forever to so 0.264, and it says that in this problem we're supposed to round to the nearest tenth, so we're going to say 15.3 because there's a 6 next door, and that would force us to round up inches.